So we're going to continue solving polynomial equations graphically, and we're going to be looking at the problem that we worked on yesterday. And here we're asked to find the solutions of the equation f of x equals g of x, and we're given both f of x, a cubic polynomial, and g of x, which is just a constant function, -10. We talked about how what we're trying to figure out is where does f of x, this cubic polynomial, equal the other function, -10. And we were able to think about what that means graphically. So pause for a second, think again, what does that mean graphically? Hopefully what you realize is that what it means is where do the two functions intersect? Where do they meet? And so our plan is going to be to try and figure out where they meet. And so in order to do that, we're going to have to graph both functions, and then we're going to have to find where they meet. And so to graph the cubic, I went ahead and factored my cubic polynomial. And you'll note that in factoring the cubic polynomial, you might have to use the quadratic formula to find the roots of the quadratic. And then in doing that, you'll find that the other two roots are at -1.3 and positive 5.3, and that will allow you to graph f of x. G of x was easy to graph, it's just -10 all the way through. And so then the question is, where do our two functions intersect? And there's one spot where we know they have to intersect. That's somewhere to the left of 1.3, because after -1.3, after -1.3, my function continues down forever, and so at some point it must intersect -10. However, in between 0 and 5.3, the other two roots, we notice that while it's negative, we're not sure. It could go like this, could follow the dashed white line, or it could follow the green path and intersect. In fact, it could also follow a path where it just touches once and then comes back. And so to figure this out, as we spoke about earlier, our method is going to be to just try points out. We're going to make a table and try some values out. So to give you an idea of what that looks like, I would create a table with x values and then f of x values. Now we know, here's the good thing, we know g of x is always -10. So when we're trying values, we only need to try and plug them in for f of x. So for example, when I'm looking to the left of -1.3, let's just say I try -2. Now it so turns out that when you plug in -2 into f of x, you're going to have -2 cubed, which is of course -8. So I have -8 here, and then I have 4 times -2 squared, which is also 4. So I have -8 minus 4 times 4 is 16, so -8 minus 16 is -24. And then 7 times -2 is -14. So the negative times negative will be positive, so I have -24 plus 14, and -24 plus 14, sure enough, is -10. So that's exactly what I'm looking for, and so I have here a point of intersection. Now, to check values to the right of 0 and to the left of 5.3, I might just begin trying a couple out. So let's, for example, say I try the value 1. When I plug in 1, I'll have 1 cubed, which is 1, minus 4 times 1 squared, which is -4. So I have 1 minus 4, which is -3. And then 7 times 1 is 7, so I have -3 minus 7, which is also -10. Which means that when I'm at 1, my line should intersect. So I might have to redraw this. It comes down, that's even not steep enough. It comes down steeply and intersects right there at x equals 1. And then since it intersects at x equals 1, my guess is that it's going to continue moving downward and then come back and intersect somewhere else on its way back up. And so I can keep trying values, and you should do that. Go ahead and pause the video, try it out. And eventually you're going to get to 5, and when you plug in 5, go ahead and try that, you're going to end up getting negative 10 as well. And so that's another point of intersection. And so the solutions to my equation, and I'm just going to write the answer up here, when x is equal to negative 2, they're equal. When x is equal to 1, they're equal. And when x is equal to 5, they're equal. What does it mean for them to be equal? It means they have the same value, or in other words, they're in the same exact place. So for any of these x values, negative 2, 1, and 5, the functions will intersect. We want to look at a couple of different examples, and I'm going to have you try each of these on your own first, and spend at least 3 minutes getting started and then work into the video. So go ahead and try that now. Okay, the functions f and g are shown below. Give the approximate solutions or solutions to the equation f of x equals g of x. So the first thing is, what are you asking yourself here? What are you trying to find? And you've got to hone in on what the question is saying. It says solutions or approximate solutions to f of x equals g of x. What does that mean? What it means is, where do f of x and g of x have the same value? In other words, where are they in the same place? Where do they intersect? And the key piece is, where do they intersect? I want you to say that silently to yourself. Intersect. Where do they intersect? And so I'm sure you can find that easily, but the key here is understanding that that is what you're trying to find. So go ahead and pause again, and go ahead and try and find those approximate solutions and check back. All right, so you'll notice that the two functions intersect at 3 spots. Okay, and you want to give some approximations to what those spots are. So let's go ahead and move from left to right, and let's look at this point here. This point appears to be in between negative 10 and negative 15, but closer to negative 10. So I might say that x approximately negative 12, right? Because it's closer to 10 than it is to 15, negative 10 than it is to 15. So I'm going to say approximately. That's important because that's not exactly where it is. It's approximately there. Let's move to the next point. This appears to be in between negative 5 and 0, slightly closer to negative 5. So I might say that that's negative 3, maybe negative 3.5. I'm going to say approximately negative 3.5. I want to be as precise as possible, and it seems to me like this would be 2.5 here, so you could make an argument that it's at negative 3. I'm just saying negative 3.5 to be a little contrarian, a little different. Moving to the next point, this point happens in between 5 and 10, but definitely much, much closer to 10. And in fact, I'm going to say that's when x is approximately 9.5. And so the points where they intersect, where f of x and g of x are equal, is at approximately these 3 points. Notice that they didn't tell you which was f and which was g. It doesn't matter. We just know that we're looking for when they're equivalent, and that is when the two lines will intersect. All right, one more question for you, and I want you to spend at least 5 minutes trying this out. Write down what you're trying to find, make sure that you are settled on that, and then come up with a plan for yourself, and then only once you've done that, go ahead and start working towards it. Keep trying. If you get stuck, go back and look at your plan, and only then press play, and we'll go from there. Okay, find the real solutions of the equation f of x equals g of x, where f of x is negative 5 and g of x is the quartic function described below. So what is it asking us to find? It's asking us to figure out where the solutions, the x values, which will make f of x equal g of x. So in other words, which will make f of x, which is negative 5, equal to x to the 4th plus 4x to the 3rd plus 4x squared. And think about what that's saying. That's saying, when will the left side be equal to the right side? Okay? When will g of x have the same value as f of x? Now, does f of x's value ever change? No, it's always negative 5. But g of x will change depending on the x value. And so the question boils down to, when will g of x, this function, have a value of negative 5? Now think about what that means. What can you, in your viewing two things being equal on a graph, what does that look like? It looks like the two lines intersecting. So our plan is going to be to figure out where these are equal, and that means where they intersect. Okay, so our plan is going to look at this graphically, right? We want to go ahead and graph both f and g, and then we're going to approximate or look for intersection points. Where do they intersect? Okay, so let's go ahead and create our graph. And let's start with f of x. Let's graph f of x, negative 5. Let's say that's right about there. Continues on. That's f. And g of x, we have to do a little bit of work. So in order to graph this function, what will we need to know? We'll need to know the basic shape. It's a quartic function, so it's going to move upwards in both directions since it's got a positive coefficient. If it had a negative coefficient, of course, it would open up downwards in both directions. So we know the basic shape, and now we need the roots. How can we find the roots of this function? Well, let's think about it. I mean, what would we have to do? We'd have to factor out somehow, some way, we'd have to get the linear factors of our function. So let's try doing that. And I want you to stop and try this on your own. So pause the video, try it on your own, and try and work all the way through the problem. And only once you get stuck a couple times, come back. All right, I hope that went well. Let's go ahead and just take a look. X to the fourth plus 4x to the third plus 4x squared. How can I factor this? And we're going to look for what these have in common. Okay, we're going to try and pull out some terms. You might want to say they have an x in common, and they do, but they have more than that. Each term actually has an x squared, two x's in common, right? There's an x squared here. X cubed is x squared times x, and x to the fourth is x squared times x squared. So I can pull out an x squared, and I'm left with x squared plus 4x plus 4. And that's great, because x squared, do I know what that means? I should, right? It's an x and another x. It's a root of multiplicity 2, right? And it tells me, when will this function be 0? It'll be 0 when this factor is 0, and that will be when x is 0. So I know I've got a root right there at 0. And I can factor out, I have this x squared term, and I can factor the remaining quadratic function. So I know it will be x and x, and then what will multiply to be 4 and add to be 4? Positive 2 and positive 2. So now I've got a really simple situation. X plus 2 times x plus 2, well, those are the same thing. So I have x squared times x plus 2 squared. So I have two linear factors that have multiplicity 2, right? I have an x times an x and an x plus 2 times an x plus 2. So my second root is going to be when x is negative 2. Okay? And now we're ready to graph. So let's think about, remember the basic shape, it's positive, so it opens upward to the left and upward to the right. What will happen at each of the roots? So let's start with the root at negative 2. When I hit negative 2, will this linear factor change sign? The answer is no, it's squared. So whether I'm to the left of negative 2 or to the right of negative 2, this factor is always going to be the same sign. So it's never going to dip below the x-axis. It's going to bounce up. Then I've got to hit that second root at 0. And it's the same thing. It's squared as well, so it won't change sign either. And so there is my function. So the question is, where are they equal? What does it mean for them to be equal? Go back to our plan. We've graphed both, and now we want to know, where do they intersect? Do these intersect anywhere? Do they have to intersect anywhere? The answer is no, right? There is no way this function can ever be negative. So there's no way I can ever get to negative 5. And so the answer for the first part is simply that there is no solution. No solution. What does that mean? That means there's no x value. I want you to write this down. There's no x value which will make f of x equal to g of x. And I want you to write that down, say that to yourself again, and then only then move on. All right, we want to define another function, k of x, for which you know g of x will equals k of x will have a real solution. What does that mean? We want to have another function, because guess what? F of x didn't work. So we want another function so that when we set it equal to g of x, we will have some sort of solution. What does that mean to have a solution? That means they will intersect at some point. So notice how these didn't intersect. We want something where they will intersect. So really, what could you pick? You could pick any function that's just a positive value always. So an option might be that k of x could be equal to positive 5. That would work nicely. But also think about this. What if we had a function, what if we said k of x was equal to x? That's just the straight line that goes through 0. Well, doesn't that have to intersect? It does. In fact, they have to intersect at 0, and they're going to have to intersect another time up there. So there's lots of different options. Why don't you go ahead and choose 2 more of your own? Now come to the end, and to summarize, I want you to write a letter. And you're going to write a letter from a function x. So you're going to pretend you're some function x to another function, g of x, and your topic is going to be when you know that you guys are on the same page. When do you know that you guys are in the same place? In other words, when do you know that you guys are equal? F of x equals g of x. Okay? Once you're done with that, go ahead and write down any questions that you still have, and of course, if you don't have any questions, anticipate ones that other students will have. I'll see you guys tomorrow.